Hey there, Postgres fam. Welcome back to the channel. It has been a minute. Today was a crazy day. I think we've got some things straightened out. New changes in the world. Everything is great, wonderful. Let's pretend at least. Things are good in Postgres land, I think, for the most part. So we'll go with that. I think I forgot my coffee, but I'm going to have to go without it. So hopefully I make it through. Click a few more buttons here, as they say. All right. Everything going well. We got some feedback there. All right. Let's go for reals. Okay. So let's get into it. I've got one question, as the title may have indicated, if you saw that or not, but so many answers involved in that question. Answered so many times, you could say. Before I get to that, I want to do a quick PSA. Let's see, then we'll do the question. You'll see what I mean by so many answers. And then bits and bobs at the end, talking mostly about upcoming travel schedule. The PSA is this actually came out, I don't know, I guess last week. I actually think it was a week before that, maybe like 2 weeks ago. Postgres 17 Beta 3 was released along with a series of minor version updates. Hopefully you actually deploy those in production and everything's running awesome and all your security is now updated and all that good stuff. But I wanted to sort of make a call out for that. So if for those who are not sure how the Postgres release process works, I would say there's always at least like 2 betas. A third one, I guess it does happen. I probably should have looked up the numbers on this. A 4th beta is actually usually pretty rare. So I would expect the next release in the process will actually be the first RC1, which is a release candidate 1. And if nothing is found to be a big issue with that, usually it's the following week, but perhaps 2 weeks before the final release, the actual like Postgres 17 for reals release is put out there. So I would estimate we're within 30 days. Some discussions on pending dates has been put out there, if you know the right places to look. So you should expect that. Now, the Postgres project does sort of follow an open source mantra of we'll release when it's ready. As far as large projects go, I think they're as good as anyone else about keeping that spirit alive. So it's possible it won't get released if a big enough issue comes up, but I'd be kind of surprised if that happens. So I would say expect the release to come out sometime in September, and then you'll all have it deployed, I'm sure, by October 1st, and then we'll be good to go from there. So that's the heads up I wanted to give you. Let's get to the question. And I looked through the questions this week. I sort of, kind of troll through the questions, see what's good, if there's anything I should bring up or whatnot. So there's a question. Maybe, I just kind of, maybe it came because of the release announcement. So so one of the questions a couple of days ago, somebody asked, like, what is the main, feature of Postgres 13? For that release. And I was just sort of like, I feel like this question has arrived like 5 years too late. But now I'm thinking about it. Okay, so part of the announcement of 17 Beta 3, so PSA Part 2, is the end of life for version 12 was also announced as part of that. And that's going to be with the November set of releases that will come out, which will probably be like 17.1 and the new minor releases. That'll be the last version 12 releases in November. So heads up, if you're on version 12, time to get together. And so, maybe there's somebody out there who their upgrade policy is some weird version of we upgrade every year, but only to the very last supported release, as things go EOL. So maybe they're just upgrading to 13 now, and they were like, hey, what is the hot features of 13? So I'll answer that in a future video. Let's not talk about that today. We have a question already that we will go into. By the way, if that is the case, minimum version you should be running is 14 right now, I would say. So hopefully you're on 14, and 17 will be the new minimum in Rob's Guide to Postgres. You should be getting on 17 when it comes out. So a few changes in there. But for today, we're going to talk about something different. And I'll just jump into the question. So today's question is, what is the difference between database partitioning, table partitioning, distributed databases, and replication? And it's a fair question, right? You might say, well, there's a lot to that, and there's a lot to actually answering it. But those terms are used a little bit differently depending on, sort of what database family you tend to work with. Or, like if you're in like a NoSQL camp versus a relational camp, like it definitely could be seen different ways. So that probably leads to confusion about what these terms mean. There's also a bunch of overlap between them. So maybe I can address some of that. I am going to mention, though, that if you look on the channel, I've got at least one version of this talk I did a number of years ago, maybe like 10 years ago or something, which is called Database Scalability Patterns. And it's really about fundamentals. So the fact that it's old is not the problem, other than the video quality and audio quality. Like I can't speak to that. Like it's probably not great. It is funny because assuming you can get a thing working, like your phone is actually shooting better video quality than what we were paying a lot of money for at those conferences. I know, I helped organize them. I saw the bills. Like we're paying a lot of money for the audio and video for that stuff. So, and it wasn't always great. So in any case, if you search for that, and I'll do the link in the video thing, right? So I'll do that. You can do that. It's about an hour-long talk, and the way it sort of walks through a lot of these things that I'm about to sort of give you the high level of is like take a database that you have, and then as you're growing your business, as you're trying to scale your database system, what are some of the patterns that are often used by companies in that situation, right? And I did that back when I was doing the scalability consulting stuff for OmniTI. So you can check that out. And if you want to deep dive into it more after seeing today's stuff, go check that video out. I've also done some on partitioning itself. So you may want to watch this as well, but I think the database scalability patterns would be the one, probably is the one to go dive into deeper. So, but today, let me go ahead and answer this. I'm not going to actually answer it in the order that it was asked, those sort of 4 bits, because I think it's easier to think about it. And we'll go from, I think, the term that I think is the most commonly used and known, and then I'll sort of layer on how the other ones fit into this whole thing and some of the caveats of it all. So let's start with what I think is the one that most people understand, which is table partitioning. And table partitioning, there will be caveats to this before I'm done, but table partitioning, basically the idea is you take a table within your database, and we're talking on a single database instance, right? So one machine, whether that's virtual, physical, hardware, whatever, but one machine. Inside there, you have a database instance running Postgres. Inside of there, you've got a table, let's say like a payments table in a pgconf sample database. You take that table and you say, this table is going to be super big, or I've got like some kind of maintenance thing that I need to do. Like it's going to be heavy update activity, but I don't need the whole rows. Like in Postgres, there's a couple of different reasons why you might do this. In other databases, probably it's like performance is the main thing, but there could be other sort of reasons. But anyways, you're going to take that table and you want to keep it the same from a logical standpoint, right? So the application would still look at it and think of it all as one table, but on the underside, you're going to partition the table, which is basically making segments of the table physically on disk that are distinct from one another, but wrapped together in a bow so they present as one logical table. And the way Postgres used to do this was with object inheritance, table inheritance in Postgres, and now it's all kind of built in. And most other databases in the relational field have this, MySQL, Oracle, SQL Server, I don't know, DB2, I'm pretty sure had it. So it's a common enough feature in that sense. I feel like most people are pretty familiar with that. And again, like it's just to like sort of better manage data, maybe do some performance improvements depending on your system and your workload by doing the segments physically underneath, but with the same sort of logical presentation. But you're keeping everything in one database, like on one instance, on one piece of hardware, right? And that's sort of key to the table partition definition, right? And I will give you the caveat in a minute, but you can think of it that way. That's a simple sort of version of what is table partitioning. So database, and you could do, I will say this because we'll talk about database partitioning here in a second. Typically, like the most common pattern is like time series kind of data, where you're just like every month, right, I'm getting rid of the old data, so I dropped the old partition and I put them in the new ones. But you can do this kind of on anything. So if you had like a users table, you could do like take the user ID divided by 10, create 10 different partitions. You could take your customers and make 50 partitions and put each state code into its own partition, right? If you're like within the US, you got 50 states, something like that. I want to say like 17 provinces if you're in Canada. So maybe you would do 17 partitions, whatever. Um, However, you would split that up. You could do it that way as well. So you can kind of build your own algorithm. When it comes to database partitioning, it is sort of the same concept of table partitioning in that you often are sort of keeping the idea of a logical schema over a database from an application perspective, but then physically underneath what you're actually doing is segmenting off to different databases, right? Your slices of the first database that you had, right? The starting sort of database. So logically, you think of it all as one system, but physically underneath, these end up being different databases. And you can either more tightly or loosely couple these systems together. I'll get into that in a minute. But let me give you so if we took that same user's idea, and maybe you would do table partitioning on a single node, if you're like, I don't know, I'm going to have like 10 million users, so maybe I want each million to be in their own bucket or something like that, right? Okay, but maybe you said like, well, I'm going to have 100 million users or whatever, a billion users, right? So I actually want to segment them off onto different pieces of hardware, virtual or physical, right? So those are going to be totally different instances that are running on separate machines, essentially. And from an application perspective, you probably are still trying to keep the idea that like, well, it's all one user's table. It just lives on 10 different machines now. And you take the user ID and right, you split it by 10 and just dump each one onto the appropriate database. And when you do database partitioning, that one of the reasons for that is, I mean, performance still plays a role in that as to why people will do it. But another piece can be like availability, especially as you get into more complex setups. But you're like, at a minimum, you would say like, well, if one of these databases goes down, maybe I'm doing a major version upgrade. 90% of my user base can still like log in, right? If it was like a user stable. And maybe like 10% will be offline for a few minutes while we do the upgrade. So you can get like better availability in your system by doing that versus if it was table partitioning, right? Like you still got to restart the database, so like everybody's done. So now we don't typically actually use. One of the reasons I think this is a little bit confusing, we don't tend to use the term database partitioning a lot anymore. I think what most people will actually call that is sharding, and that's fine. Like there are kind of two ways you can do sharding or database partitioning. And I don't think there's like a really defined version of each of these. So one is this sort of user's ID, and then we split it out based on some kind of algorithm. The other one is like functional partitioning, where you think of your schema. So like if we took the Pagila one, we've got like a users table, and there's like actor film info, there's payments info. Maybe let's imagine that we added a forum system into our database. So now we got some tables for the forums. And as that thing scaled, you might say like, well, the performance profile of these different pieces is wildly different, right? How often do you get a new customer? Like you get those pretty regularly, and there'll be inserts and updates on that. But by and large, that's not a heavy amount of traffic. For every new customer you get, though, you do expect to get some multiple of payments from them. So your write load on a payments table will be heavier. The way the Pagila schema is, you'll actually will have inserts and updates, one each, I think, per row. Maybe not for payments, that's for rentals. So that actually would almost be like an insert only table, I think, is how you would look at that. Whereas customers are going to update, like their address info and stuff like that. So they probably will have insert update workload. Payments will be more inserts, but probably close to insert only. Whereas a forum, depending on how the forum software is written, would be even more is because you expect multiple forum messages a day from each person, more forum posts than payments probably, and maybe there's heavy updating within those forum posts as well. So you say, look at the workload, the performance profile of these. I want to split off like forums into its own database, and I want to split payments off in its own database, and users into its own. Maybe that's a login method for everything, and then actors and films can be its own database. So you shard the database, right? You're cutting it up into multiple pieces that will then go live on their own database systems. So those are kind of the two ways people think about database partitioning and sharding, and the two sort of approaches to it. And you can mix and match, right? Like you could say like, well, I want the forums to go to this one, but I'm going to like segment by country or language or something like that. And so then underneath the forums thing, we're going to split it out with an algorithm based on language or something. So that is sort of database partitioning sharding. And the key bits there versus like table partitioning is we're talking about multiple databases on multiple instances, multiple pieces of hardware, again, whether it's virtual or physical hardware that are going on there. So that's sort of your database partitioning and sharding. You could also, like we did this for a few customers where you take something like the payments info and maybe it's for compliance reasons where like that needs to be PCI managed. So I'm going to move it into its own system to reduce the footprint of what has to be managed up to PCI compliance levels, right? And so then I make the payment stuff all super secure and PCI compliant, but the rest of the stuff doesn't fall within the domain of that, right? You can sort of set up some segments to keep those things separately. So, but you might still think of it all as kind of one big system. And so that's, sharding if it's coming out of the database and going over their database partitioning. Where do the other two things, replication and distributed databases, come into that? Well, I guess let me do replication first, because I think most people kind of understand the idea of like we write into a system and then it replicates the data someplace else. If you're doing database partitioning, replication could very well be involved. Usually when you first start to do the split, it is, we often do this as like ad hoc replication systems that we would just build because we were pretty good at that. But you could use like something like logical replication to do segments of it off to different servers if you wanted to, and to keep certain data up to speed, like you might continue to replicate that data. If you think of something like Citus, where you have a primary node generally that you're going to interact with, and you don't have to do it this way, but this is sort of the classic Citus model. You talk to that primary node, and then it is, replicating, or sort of, because it doesn't keep the data on the primary. So you might argue that's not replicating. But if you are actually writing to more than one node, which might be a thing, you might say, like, I'd like every piece of data to be written on at least 2 nodes out of like my 10, right? So that, again, when the thing goes down for the major version upgrade, like we do that restart, everybody will actually still have availability because we know that they're still living on at least one up node. It's kind of like the old RAID disk stuff back in the day, right? Thinking through it that way. So you can use replication for that and build out sort of cluster activity with that kind of stuff. But I think in the traditional sort of replicated topologies, we have a primary and it replicates out to read-only nodes. If you think of a system like Aurora Postgres from Amazon, right, it's the proprietary fork that they have. They do some like magic under the hood to do, some nice write replication stuff out to these reader nodes. And you can think of that as like an Aurora cluster, right, with one primary writer and then these read replicas that are out there. And if the writer dies, like it just promotes a read replica up to be a new writer, and all that stuff is handled more or less magically for you on some level, for some version or some value of magic. In any case, so that's running. So some people might argue that system is a distributed database. To me, like, I don't think of that as a distributed database. If you want to make the argument and you feel strongly about it, I'm willing to let you win those points if you need to for some odd reason. What I tend to think of as a distributed database are databases that are designed to be multi-node from jump, and everything essentially lives in a multi-node world. Typically, you would think of this as like you've got multiple servers running. There's sort of a logical token ring on those with some kind of distributed hash table that determines like where rows go. And when you make a table, like it's spread out over whatever number of nodes that you have in that. And that's usually configurable. In the Postgres world, like the example to me that maybe people have heard of is Yugabyte is sort of the big one. It's I guess it's a fork of Postgres on some level. And it's designed that way. So it's a multi-node cluster all the time. And you build schema on it, and it sort of does all the magic behind the scenes, right? So your app doesn't really have to know anything about that. Yugabyte is kind of handling where the data is going to live and getting the data depending on where you've connected and all that stuff. And one of the differences is that usually in those systems, it doesn't matter what node you connect to. You connect to any node, and the individual node figures out where to go get the data from. And yeah, it's better if you have some knowledge. This is sort of the sales pitch is like your app doesn't need to know anything about where the data lives. And then the reality comes and it's, oh, well, you're definitely better off if you are pulling the data off of the node where it already lives, right? Rather than having to go over the network to get it. So, but in any case, like that's sort of part of the thing is that you don't have to know necessarily, and the cluster will figure that stuff out for you, both where it goes and when and how to go get it. And then you can usually do something like a rolling upgrade across the nodes. PG Edge is sort of another version of this. Under the hood, it's more like it's base Postgres, much closer to an actual. I think you could almost do binary replacement, and I don't think it would break. Although their marshalling stuff for what manages the cluster is proprietary. I think using Gigabytes is not like it's not Postgres community like open source thing that's there, like because they've got their own pieces to all that, but it's 100% open source licensed. Recently reconfirmed in light of other databases that don't care about that kind of thing. But PG Edge is there, uses almost like a Postgres licensed Postgres under the hood, and then it has its own sort of I guess it's BSL licensed management software on top of that to keep the nodes happy. So that's another one that you could use. Now, where we get into the rub is always like, is something like Citus, why is that not a distributed database? And part of me says that the reason for this depends on how loosely and tightly coupled these systems are and whether something will go down or not. Especially now that Citus, you can actually connect to those worker nodes and do some inserting and updating. It's not quite as smooth, or magical as what Yugabyte would do in the same vein, but that's because the database is just kind of designed to operate a little bit differently. Citus is sort of spreading that out, but from an original sort of single node idea, whereas Yugabyte is like multi all the time. If you go to the NoSQL world, I think it's a little clearer if you look at something like Cassandra or my old favorite, which was React, which I think still lives out on the internet someplace. It was open source, written in Erlang, because of course. And I actually really did like it. It's very operable databases. They're really nice. I think the Erlang maybe scared a lot of people. It's funny though, because like we ran RabbitMQ a fair amount in places that we were managing stuff, and we had way more problems with Erlang and Rabbit as a thing, and we never really had those problems on React. So it's sort of a shame that didn't catch on better, but that's also out there. And again, like those ones, like you spin up the cluster and every table is like multi-node, right? Like there's not even really a concept of a single node. I think you maybe could force that, but everything is designed to be multi-node and for you to not actually have to care from an application developer standpoint until you get into like, nuts and bolts performance stuff. So, so to me, like those are distributed databases. They're sort of more tightly coupled as that they operate as a system. Now, just to sort of close this out, I'll give you like, here's the horrible idea that don't do this. And if you'd like to do table partitioning that involves database partitions, some form of replication, and is a distributed database, arguably, what you could do is you could take something like your users table and say, I'm going to implement table partitioning. And I think you can do this in Postgres, but please don't. And I'm going to make new partitions, but those partitions are actually going to be foreign tables, right? So we have a very tight coupling out to other servers, other Postgres that are running that have the data that we're looking for. And then we will use logical replication on those to write the data onto more than one node behind the scenes. So now we have a tightly coupled multi-node system that is extremely brittle and likely to fall over. It's one of those like we're so eager to figure out if you could do this, you didn't stop thinking if you shouldn't do that. But that if you wanted to tie all four of those things together into one system, I think you could do it with Postgres. So power to the Postgres. All right. So that's the answer to that. Again, if you want to go deeper onto that, I'll figure out how to do the link to the video for my database scalability talk. Other than that, speaking of talks, let me give you some schedule stuff for the rest of the year. Probably the big one, I don't know if I've mentioned this elsewhere, but I am going to be speaking at pgconf.eu. That is in Athens, Greece, October 23rd to 25th. I believe I'm speaking on Friday, so that's really the only day you need to go. But, that should be a good time in general anyways. I think Athens sounds like a pretty interesting city to go to. But I'm doing a talk there, vacuuming large tables or something like that. And we're going to look at both a disaster sort of wraparound scenario that I, had the pleasure of being a part of, and also look at some of the improvements and changes within Postgres over the last like 5 years or so. I think of like, I don't know, I don't know yet if they have actually eliminated, because part of it is 17 changes. So I don't know if they've eliminated wraparound as an enterprise issue. Probably not. But boy, they've come very close. They've eliminated most of the issues that are there. So I think the last piece of the puzzle is 17. And while I say everybody needs to go to 17 once it comes out. So that'll be at pgconf.eu. I'm also still, as mentioned, doing a talk at Past Data Summit. That is in Seattle, Washington. That is in November, the 4th through the 8th. So not much turnaround time between those two conferences, but I'll figure it out, man. I'll figure it out. If you are going to go to Pass and you haven't bought your ticket yet, definitely use the code TREATR24. You get $150 off your ticket price. So strongly would encourage that. And then the third, I'm doing a third one, or I'm going to show up at, and boy, I probably should have wrote this down because I don't remember what conference it is, and I'll feel bad. Somebody's going to give me a hard time. There is I think it's like the Seattle Linux User Group Conference, or some of that. It's a one-day event the Saturday after Past Data Summit, which ends on Friday. Maybe it's the Friday, Saturday. But in any case, I'll be there on that Saturday. I'm not doing a talk because I'm a bad person and missed the talk deadline. But I will be there, and I would also I might be in the community booth. I believe there will be one, but the Seattle the Seattle Postgres user group, they got their act together, so they probably actually don't need a lot of help. But I'll be around anyways. So look for me there. If you're in Seattle and you're not going to Pass, like one, you should probably go to Pass, but two, you should go to this like open source conferences there as well. So hopefully I'll see you at one of these things as we close out the year. Other than that, I think that's it for now. Looking forward to the release of 17. Should be pretty interesting. I should do a little feature-y video on that. I've been combing through release notes and testing stuff and all that jazz. So we'll see if I can get one of those out in the next month or so. Other than that, that is it. So take care of yourselves, folks. Until next time, if you can, take care of your database as well. I'll see you in the next one. Cheers.